I'm here with Joe Bellis at Matsuura's Additive Manufacturing Facility, and you're in for a real treat now because not just have they got quality product here, but Joe himself is, I've just been talking to him off camera, and your knowledge, I just have to get across onto camera, Joe, because it's so important to see the technology, but learn what it does, how it works, and how it can affect people. So, great facility you've got here.
Yeah, thank you very much.
Well, let's start with HP because this has obviously been where you Matsuura first embarked really on 3D printing of plastics, wasn't it? I know you got the Lumex for the metal and the subtractive and additive, but just explain what the HP machine is and how it prints, its functionality and what it's for.
Yeah, so like you say, it's a polymer 3D printer. HP came into the market to basically disrupt the market, where polymer 3D printing was known for prototyping. Well, HP's whole go-to-market was about production, and basically that is predominantly where we sell it into now, is production environments.
Well, let's have a look, because for the camera we've got the lid up, for want of a better word. If you go this side, Joe, how does this machine print? What's the process?
So it uses powder is the base material, so it's a powder-based system. And it uses printhead technology. So what happens is we deposit a layer of powder, and then what happens is the print arm goes across, and from printheads we deposit a fusing and a detailing agent. The fusing agent is there to create the component, and the detailing agent is to basically create the fine detail and basic tolerancing, and basically to create a divide between the unfused powder and the fused powder. Okay, now you're layering about 80 microns at a time, I believe, aren't you? So it doesn't matter how big the part is you're printing, it will still do it at the same speed, which is one of the advantages of this type of printing. That's it. I mean, you'd never do it, but if you wanted to print the full build area as a single pass or single layer component, you do that in the same amount of time as it take you to do one small component. Basically, it's 8 to 12 seconds depending on which system you use. So this is where your build unit would go, and you could buy as many build units as well. I suppose you don't need to, wouldn't you? You need one in there and one when you take out to replace it if you wanted to keep it running in production. Yeah, that's it. Some people tend to go to 3, just makes their life a little bit easier. But typically, you don't want to start. There's no point, adding more and more build units if you're not able to use them. That's it. So 3 is probably where you'll sit sort of maximum that you really need to go to. If you are using different materials, typically you'll have a dedicated build unit to each material, or dedicated build units to a specific material depending on how much you're printing. But typically 2 to 3 build units is what you need. But this is where you're taking 3D printing into production, isn't it? That's it. It's fast and it can produce that quantity of components. It's similar to what we do next door. You've got a pallet changing system on the machine that allows you to basically do back-to-back machining, reducing the setup time, and that's exactly what we're doing basically. While you're printing in here, your second build unit is being set and prepped full of powder. Once it's finished, it's 20 minutes cleaned down, and then the next one goes in. And that goes off to cool, and then when you're constantly switching them around. So the first print that you do, obviously, depending on which system you use, 16 hours for a full build on the 4200, 12 hours on the 5200. So if you're doing the 4200, the first time you'll take it out is 32 hours later, because you'll do the print and the fast cool. But following that, you're taking a build out every 16 hours. So it's only that initial build to get you started, and then you're taking them out every 16 hours. Or depending how long you do a build for, if you do an 8-hour build, it's 8 hours cool. So it's usually like for like. Okay, it's quite interesting to hear the other week, Joe, you've almost got 80 of these machines installed now in the UK under your under Matsuura, which is quite impressive. Since 2018, is it you've been supplying them? If you want to step this way with. Yeah, it's 2018. Desktop metal. We talk about printing plastics. This is something that really interests and excites me, because a lot of people talk about this as the future. Replacing some of the subtractive manufacturing. Of course, you've got your Lumex, which does additive and subtractive. But here you're printing metals, and I believe you can change from different types of metals very quickly as well. Yeah, this is it. So this system really, this is for prototyping or job shop type work. So basically, I'd say there's a lot of metal systems out there, but this is probably one of the easiest to just switch between materials. And the way we feed?
Sorry,
and the way we do that is through the use of cartridges, which are loaded with dowels of material. So when you want to change materials, once you've done a quick clean down, you basically change the cartridge and then you load the next material. So you can go from printing stainless to copper the next build to titanium. It's very easy, but it's not, you're not getting the throughput on here as you typically get off a HP machine or like the shop binder jetting system.
Okay, which we'll see in a bit. But
Yeah.
here's an example of what you're printing in here. Then is it? Can you just tell us why you've chosen this to print and what it illustrates? Really?
Yeah, so it's obviously a gear, but the idea with it is basically, rather than being a solid infill, we're using a gyro structure. So you're trying to keep or maintain the strength using a structure which is known for transferring the sort of load uniformly to basically, so you're stripping the weight out of it, but you're keeping or maintaining the strength. So what happens is, what we do first is create the support, or the raft as we call it, and we build that up, and then from there we then deposit a ceramic layer from the second print head, and that is there to create a divide between the support and the component.
Okay.
Then we print the component, and then depending which material you're using, so most materials can now go from the printer to the furnace, and there's a debind process as part of the ramp up as you're heating the component up inside the furnace. Or if it's copper or titanium, it goes into a debinding machine and then into the furnace. But what you're left with is a part that's nearly 20% smaller than the component that you've basically printed, and it's separated from its support structure.
And you'll see in here, if we get the camera in there, you'll see it's
the
like a
gyro.
light weighting mission, isn't it?
Yeah, that's
really?
it. I mean, you know, that's like we said before. You know, a lot of parts are over-engineered because, yeah, the way metal was formed previously was it was either forged or cast, or, you know, that was the way parts were made. Whereas with this technology now, you can deposit the material as and where you need it. And for this application, yeah, the gear, you could have it solid, but it was way over-engineered and basically would, you know, do easily the job that it was made for. Whereas with this, you've basically removed the mass and it does exactly the same job.
Yes, it really is fascinating technology, Joe. I look at this and I just think it looks like something you could use as a hobbyist as well, doesn't it? To just, you know, experiment and create parts, create prototypes, and learn.
That's it.
Great for education.
Yeah.
Yeah.
Well, that's it. It is very popular in education. That's it, because you get students obviously do student projects,
Yeah.
and it's a very easy machine to set up and use. Hence why it's sold well into that sort of educational market.
Okay, let's move on to kind of similarly, but it is a different technology to the HP, isn't it? The robos. Yeah. I mean, if you didn't realise, Matsuura supply all of the products that we've talked about and more. You can come here to their facility in Colville to see them all in action and talk to Joe and extract some of this knowledge that he has, which we're doing today. The Robos Argo 500. Now, what's different with these machines, Joe, compared to the HP technology?
So it's a different process. So this is FDM, which is probably one of the oldest 3D printing processes. But where, you know, it's typically, again, it started out as a prototyping technology. Robos are basically, it's an FDM on steroids, basically. So they have designed it on a sort of CNC platform, so the repeatability and sort of the level of production you get out of it is very good, yeah. There's also patented technology to help basically process high temp polymers, which is predominantly where we're sort of selling this into. It's high performance applications. You know,
give us an example of what a high performance application would be.
Yeah, so motorsport, aerospace, defence, oil and gas, those sort of things. So where you're, you know, if you're making a part out of PEEK is quite an expensive raw material. So if you can print near net shape, there's no doubt an FDM print, you aren't a CNC, you haven't got the accuracy of a CNC component. But what you're doing is then a small, minimal machining process to basically clean up the areas for it then to be located into an assembly of some sort.
Okay, well, and what is the main difference then between the HP and this technology that you talk about? One's layering and this is depositing.
Yeah, I'd say the material range on this, you've got a lot more sort of range as far as like the performance of the material. HP, we've got nylon, we've got TPU, we've got polypropylene. Whereas with this, we're going up to like your PEEKs, PEX, Ultem. These are like high chemical resistance, high temperature. I mean, we're melting PEEK at what, about 430 to 450 degrees. So you can imagine, yeah, you don't want to be seeing that temperature, but all the way up to there, and you know, it's not going to quite see that sort of temperature. But a lot of applications where you need that temperature resistance and chemical resistance. That's where this is well suited.
Okay, now I want to just come this way, but because before we go to the post-processing, which is obviously an important part of the 3D printing process or the overall process.
Yep.
Desktop metal, we saw one of the machines in there. Now, this one is more geared for industry, for production, again, metal printing.
Yep, exactly. So where that was sort of job shop, sort of one-off type work, this is more for serial production. You're still not mass production, but it's a really nice sort of bridging technology. So if you are making parts via casting or metal injection molding, this really sort of lends itself to being a replacement, because you've got also like the freedom of not having to manufacture the same part multiple times because you've got a mold or a tool. You could basically have 100 different components, so they could all be slightly different.
And is it the layering method that we saw on the HP that is similarly used here for this, but on a metal?
Yeah, exactly. So yeah, printhead technology, but you're depositing a binding agent onto a metal powder bed base. Yeah? We're not curing in this machine, so there's basically two stages to it. So there's a post-cure, which is done in the oven, so you take the full build box, that goes in the oven. Post-cure, that solidifies the parts enough for you then to break them out in the depowdering station. You've then got your green state part, which is then put into racks, or if it's one big part, it goes inside the sort of build box, and that is then put into the furnace for sintering. So it's a longer process, but as far as sort of like metal manufacture, it's a very good solution, especially if you're replacing, like I say, metal injection molding and casting. To bring that sort of technology in-house is very expensive, because you don't just need one machine, you need multiple machines. You need CNC machines to machine the tooling, or if you've got like a casting process, then you need to create the sand molter. Whereas with this, you've basically got like a small mini manufacturing
cell, and you can
that's it.
do it all.
That does the whole lot.
And Matsuura yourselves, you and your colleagues, I mean, this has grown massively since 2018, isn't it?
Yeah.
You've got and that's why the importance of this tool, really, to see the breadth of what you offer here.
Yep.
We've looked at some of the 3D printing solutions. Now I want to talk about some of the post-processing that you do, which is, as we've said, is equally as important. Taking the HP machines that we started on, this is the station now where the finished part comes on. It's a crude thing to say, but cleaning, how do you describe it?
Yeah, it's the post-processing station. I think the thing people like about the HP is that, I mean, HP, like I say, thought about everything, a lot before they launched this product. And the workflow for a powder-based system is very clean. And partly is the fact that basically the build unit can come out of the printer and into the processing station. So what we do here is we fast cool. So what happens is you've got basically a top cover that goes over the top of the build area. This will be filled up with powder, so this will be solid up to the top. You put the cover over the top. This nozzle here is fixed into the top, and that's basically pulling any loose powder away and helping aid the fast cooling process. Yeah? Once we've done the fast cool, and it will tell you when it's done. So and it's very clever. The build unit is basically feeding from the printer, so it's basically connected to the printer, and once it's finished there, this knows exactly how long it's been. Yeah, everything is communicating. It's very clever. So once it's done its fast cool and it's prompted you, what happens is then this nozzle then becomes a full-on vacuum, and what we're doing is we're recovering any powder that we haven't basically fused. There is a fine caking of powder that's left on the part, so you'll see that's sort of what you're finishing with.
Yep.
But everything else we're recovering, and basically what happens is it's taken through here into a sieving unit, sieved and then pumped into the storage tank, and that then is used in the next build. So what we do then is we pull 80% recycled with 20% fresh, goes up into the top of the processing station, it's blended, and then it's pumped through this nozzle into the build unit, ready for the next build.
Ready for the next build.
So if you look at other powder bed processes, sometimes they can be blending the powders in like cement mixers. It's very messy, whereas this is, like I say,
well, they talk about the 80-20 rule, but to use 80% recycled, that's really, really efficient.
That's it. It's a good tick in the box. People are always looking for minimal wastage, and that's where 3D has come on leaps and bounds, basically. That's it. Where subtractive processes, you know, you are
harder.
losing, like the medical industry, yeah? So they'll start with a block like this to make a sort of insole that's like a fraction of the size. And all that wastage goes in the bin. And it's like, for the medical profession, especially, you know, along with other industries, it's a massive thing for them to look more sustainable. So, and shipping stuff around, you know, logistics, if you're shipping insoles like this, you know, it's a bit different to blocks like that.
PowerShot C, so Dimension products then, this is part of the finishing process. This is for extra cleaning of the part. Is it, what happens here, Joe?
Well, that's it. So we wanted to complete the solution. So when we first took on HP, I don't know what, 5 years ago now, we needed to complete the solution, because you can give people the grey raw part, and that, people are happy with that, but then Dimension takes it to the next level. So basically the first thing is to automate the cleaning process. So when these guys are in production, these parts aren't too bad, but when you've got, you know, hundreds of these smaller parts in a build, to have somebody stood there manually blasting each of these, it's time consuming and it's laboursome work. Whereas with this, what happens is 75% of a full build off the 4200 or 5200 machine goes in here, and in a 10 to 15 minute cycle, they come out completely powder free. You then take it from there, and basically you've got a few options. You could use that as it is. A lot of people do. People like the raw state part, and you'll either have a grey raw state part or a white raw state part now, with HP's obviously advancement in producing white components now. The next stage is you can either vapor smooth it, which will basically give you a smoother part. So what we're doing is hanging the parts on in the racking, and you can have this with like an auto loader, again a bit like a pallet system. So basically you hang all your parts, and with the auto loader you'll have about 5 baskets set up, and what will happen is the auto loader will just keep feeding them in, and it will do like 2-hour cycles, pump that one out, pulls the next.
What's it doing in there?
What happens is, so you hang your parts, so they're in that raw state, so as we call it, which is like, it's got a little bit of a texture to it, it's not completely smooth. So what we're doing is hanging the parts, and we use like a PTFE tape to hang the parts, and then what we do is basically the rack then goes inside the system. It's then under vacuum, so we're removing all the oxygen, and then we're purging the system with basically a chemical sort of solvent. It's environmentally friendly, so this again is a tick in the box for
coating.
Yeah, so it basically purges, and that's the beauty about it, is it gets into areas on a part that you typically wouldn't be able to access with either a blasting media or a ceramic sort of tumbling process. It gets into all the voids and spaces, and what happens is it basically sits on the surface, creates a chemical reaction which smooths the surface, and then we extract the solvent back out basically, and then the parts come out and they're completely smooth and chemical free. Whereas other processes can leave a sort of remnant on the part. So for sort of medical sort of applications, or even anything where there's going to be skin contact with the part, Dimension stands alone in that market.
And what's the difference then between the PowerShot that we see here?
And then the PowerShot again is another it's another way to get a better surface finish basically. So this uses a 0.5mm spherical ball, which you can't really see in here, but it's, rather than using like a glass media, which is about 250 microns to 450 microns, what we use here is a completely round plastic ball. It's 0.5mm. What we do with this is then the parts go in there, and the idea is it's fired at a higher velocity, and what we're doing is we're just peening over any high spots on the surface, which then gives it a bit more of an aesthetic look. So really, the only thing you need is a bead blaster, but these things take it to the next level, either for an aesthetic purpose or for smoothing. That gives us full water repellent. So if you've got like an application like the one we've got over there, which is a marine application, they didn't want salt water sitting on the part. HP can be fully submerged in salt water, but for this application it needed complete repellence and runoff, and basically that's what it gives you, as well as an aesthetic.
Okay, let's finish up this tour here, Joe. Just taking the kind of the background into site here. It is some facility you've got here to back up your machine, the subtractive offering. You must be quite proud to be able to offer this, and you must have seen, you've been involved in this journey ever since 2018. There's so much here now, isn't there? I mean, not just the machines. What is the other important things with 3D printing and additive that you've learned and you get across to your customers? Because this is all about education, isn't it? This is about that there's so much to the technologies that we've seen here.
Yeah.
You've got to be able to pull that out of you know, you and your colleagues.
Yeah, and that's it, exactly, and that's it. It's one thing having the machines, but I think unlocking the applications, and that's something we're starting to offer now. Our guys, you know, they are very good at that sort of thing, but their time is taken up, you know, running this side of the business. So what we're offering now as part of HP's professional services is the ability for us to come in and basically identify potential applications that lend themselves to 3D. And we're not coming in just to try and get you to print anything and everything. The idea is we're identifying applications where we can save customers money, time, and, you know, create a better way of manufacturing their components. And I guess the other side of it is the support. You can sell a machine, and if you sell these machines and walk away, yeah, you'll sell one, but you won't sell another one. I think that's what we've done really well. We're not box shifters, as you know. CNC side of the business, support service is critical to the Matsuura business. You know, we have good machines, as these machines are good machines, like the HP machine is a very good machine, but without the service and support that we provide, as we do in here, then you wouldn't get the repeat business. Because there are times when customers are down, there's no doubt about it. These are mechanical bits of equipment. But you are judged on how well you service and support the customers, and I think that's what we've always done well.
And not the biggest thing for me coming here and doing this tour is actually is walking around with you, Joe, not just now but previously, and actually learning about how the different technologies work and seeing how you can apply them to different industries and different parts.
Yeah.
Really is worth coming here to Colville. This is one of the best additive manufacturing sites I've seen here in the UK, and it's growing very quickly. Thank you very much, Joe.
No worries. Thanks.